Hi, welcome back. This is Tom, and in this video, what we're going to do is take a look. We're going to take a look at what happens. How do we represent shaded regions on the histogram? And in a way, it's kind of obvious. So, for example, if let's do this. I need to do one more thing before we go on. Notice this. If I have a frequency of 6, I'm going to do some editing here. A frequency of 6, well, we said over here in our graph, we said that that is equal to, in percentages, 30%. So let's put percentages now on our histogram. We said 4, well, that was equal to 20%. We said that 3 was 15%. And you can actually see this works out nicely by 5s. 2 out of our 20 is 10%, 1 out of our 20 is 5%. Now, so I've just taken my frequency on my histogram and I've replaced it with the percentages over here from our frequency distribution. Now, let's try this. If I shaded, I'll shade it this way. If I shade this first bar, then I would be asking the question of what percent of the data is represented by the shaded region. Okay, well right now I've shaded the very first bar, and we already said that first bar represents 20%. So notice that we have from the class from 0.5 to 2.5, that represents 20% of the data. Now, that's the first question. Let's try another one where I'm going to shade some more. So let's shade the first bar and the second bar as well. So, and I should maybe mark this. This was just one bar, or first bar. Okay, but now I've shaded the first two bars, so bar 1 and 2. Well, notice that in the first bar we said that's 20% of the data. And in the second bar, that represents 30% of the data. So I could say that that represents the shaded region is now 50% of the data. Now, that might seem relatively intuitive, and that's what we're hoping for. And what if I shaded another bar? Excuse me. So now I had bar 1, 2, and 3. Well, again, we'd say the first bar is 20%. The second bar has 30%. The third bar, that is also 20%. So if we add those up, we'd say that the shaded region now represents 70% of the picture. Okay, now what do you think happens? What if I shade all of the bars? If I shade all of the bars, 1, 2, 3, 4, all bars shaded, notice, well, that's going to be the 20% plus the 30% plus the 20%, and then I have two more 15%. If we add the entire picture being shaded, well, we'd say that that's 100% of the picture. Okay. Now, let's make this a little bit more. See what else we can do with this. So I'm going to erase my shading here, and let's try another one. Let's try maybe some light green. What if I just shaded this last bar here? What if I just shaded this last bar? Okay, well, notice though that's the, oh, actually, yeah, let's do that. Let's shade the last two bars. Well, believe it or not, you don't have to work too hard, because if you look at your frequency distribution, or right here at the histogram, you can see that each of those bars represent 15%. So when you say that we have bar 4 and 5 are shaded, well, that's 15% plus 15%. So you could say that that represents 30% of our data. Now, let's try another question. So remember what a percentile is. A percentile represents, if a number has a percentile ranking, it means that it's at or above that percentage of the data. So, using that, let's do percentile rankings. So for example, what a percentile ranking is, let's take a value here. Actually, you know, I'm going to bring my picture down. It's just easier than going up and down and up and down. So I'll copy that. Let's bring it down here. Paste. Put it right there. Okay. Now, notice this. So percentile rankings, we're going to try this. So for example, if I gave you the value of 2.5, well, notice that 2.5 is on the upper edge of the first bar. And also, remember that the reason for using class boundaries is that it actually doesn't contain an actual value. So you know that 2.5 is strictly above, in this case, 20% of the data. So you would say that it has a percentile ranking of 20th percentile. If I try, we could do each one of these. For example, if I look at 4.5, well, it's above the first 20% plus the next 30. So we would say this represents the 50th percentile of our data. If we continue on, we could say 6.5. And 6.5, that would be, we have 20% in this first bin. In the second bin, we have 30, so that's 50. And then in the next bin, we have another 20, so that's 70%. So it represents the 70th percentile. Now, what if I asked you for 5? What about something like 5? Well, my initial reaction is a bit of a question, because notice that 5, if I have the value of 5, it lands somewhere inside the bin. And the answer is, we don't know. If all we have is a histogram, and we're asked for the percentile ranking of a number that's not on the class boundary, we actually just can't give an answer. And so this one we would say cannot be determined from the data set. Cannot be determined from the data set, or from the given information. There. And that's what we can say for sure. I think that's all we need to do. Oh, there's one more thing. One more. So let's try this. Let's copy. No, I don't want that one. I want a different one. Let's take this picture here. Okay, so we're going to take that. We're going to copy it. I'm going to put it down here. Paste. There. And let's let's do a little bit of work. First thing, I'd like to get rid of all my green. And now, if I asked you kind of a strange question, if I said, what percent of the data is represented by the shaded region? So remember, this is the question we looked at the beginning. Well, this might seem kind of trite or a bit simple, but notice that nothing is shaded. And so if nothing is shaded, the answer is just very simply 0. So remember, if all is shaded, the answer is 100%. If nothing is shaded, the answer is 0%. And both of those answers are just as important as answers where we look at pieces in between or pieces like this one. Those are all just as important as 0 and 100. And that is how we can use a histogram and shading a histogram and the area that's been shaded to represent the percentage of the data. Thanks for watching. Hope that helps.